Okay, so today we are going to look at words going into balanced chemical equations. So yeah, you all did a really fantastic job of balancing. So now we're kind of just combining our knowledge of balancing equations with which unit was it where we named everything, the ionic and covalent bonding naming unit. We are combining those things together. So let me just okay, so sorry, I'm gonna fill this in with you all. All right. So writing phases in reaction equations is pretty important because it is important for us to know what actual state or phase things are in. So a chemical reaction equation also shows the phases in which the reactants and products exist. We have not been doing that so far. In those questions on the balancing thingy, it's just like Fe plus O2 equals FeO. Normally, we would put a little solid, liquid, or gas down here, and we're going to start doing that now. So we'll kind of see equations written in a different way. So S is for solid. Crystals, powder, or precipitate are all indicative of solids. So if you see any of those words in an equation or a word problem, are you heading out? Oh, okay, that's not good. Have you got one of these? Perfect. Okay, we'll see tomorrow. L is for liquid, and G is for gas. Oh wait, AQ is one that we're probably going to be seeing a lot, and it stands for aqueous. Okay, so liquids refer to things that are pure liquids, like distilled water. Something like the sulfuric acid that we used yesterday is actually in aqueous form. So it's something dissolved in water or solution. So most often we're going to see things that are aqueous more often than liquid. So a liquid is a pure substance that's in liquid form, and aqueous is something dissolved in water. So we do see this one a little more often than the liquids usually. Okay, so an example of taking a word problem and turning it into a equation or formula. So we need to know, first of all, the symbols for things. You can always refer to your periodic table. I'm not going to make you memorize that. Water, you really need to know that as H2O. I'm sure you guys already know that. And then goes to sodium hydroxide. So this is where our naming stuff is starting to happen. So sodium, and then OH is hydroxide. OH is a polyatomic ion. And if we look on our periodic tables, sodium has got a charge of +1. Hydroxide has a charge of -1, so it's a 1-to-1 thing. When you're doing these word equations into formulas, you need to be thinking, is this an ionic compound? Is it a covalent compound? Is it a diatomic molecule? And you're really applying all of that stuff to this. Hydrogen is always H2, right? Okay, so that's what we have, and then we have to balance it. So, our balanced equation, we can do our table here. We've got 1, we've got 2, 1 and 2, we've got 1, and we've got 1. So 3 of those total. Okay, so the probably easiest way to do this is going to be to start by just, our sodiums are okay right now. Take our hydrogens, and I would just multiply our 1 hydrogen by 2 to make 2. So we have 4. And then that also applies to our sodium. And then over here, we can multiply that one by 2 to make 4. And then we're going to need to do sodium by 4, right? Oh, no, sorry, by 2. I don't know why I wrote 1 times 2 equals 4. Okay, sweet. So that's going to be our balanced equation. So our answer is 2Na plus 2H2O goes to 2 sodium hydroxide, NaOH, plus H2. When you're balancing, if you're going through this process and you write a 1 in here, that's okay. In your answer, please just leave it blank though. So the appearance of that element indicates that there is one of them. All right. Ammonia reacts with oxygen to produce nitrogen dioxide and water. So word problems are often going to look more like this than just sodium plus water goes to. So we've got our reactant side, ammonia, which is NH3. So you'd find that on your polyatomics. So we've got NH3. We've got oxygen, which is going to be a diatomic molecule, so it's O2. And we're producing, so that means these are going to be our products, nitrogen dioxide, NO2, and water. Okay, so NH3 plus O2 goes to NO2 plus H2O, and we're going to balance it. I will give you all a minute, try to balance that one. Okay. Do we all have an answer for that? Need a minute? Okay, so I'm just going to show the answer there. So your end equation should be 4 ammonias, 7 oxygens, 4 nitrogen dioxides, and 6 water molecules. In this question, it doesn't tell us whether the things are in like solid, liquid, gas, or aqueous form. So we're still not worrying about that, but we will be seeing that later. Okay. So, if the state or phase of a chemical is given, oh, did everybody get that? Oh, sorry. I will put that back up so you can copy it down. Okay, can I go to the next page? Yeah. All right. So, if you are given the state in the word problem, or the description, make sure that you include it in your chemical equation. So in this example, we're seeing mercury and oxygen gas reacting to form the solid mercury 2 oxide. Mercury, unless otherwise specified, is a liquid. So it's a liquid at room temperature. So unless it's otherwise specified, you can assume that that's going to be a liquid. Okay, so mercury, what's the chemical symbol for that? Does anybody know it? There we go. Yeah. Somebody did it as one of the elements. Okay, Hg, oxygen. It's going to be O2 because it's diatomic. So those things are going to react. So that means that we're seeing an arrow. So react, produces, anything like that means that's our arrow to form the solid mercury 2 oxide. Okay, so mercury 2 oxide, we're seeing a what's the word I'm looking for? Multivalent ionic compound. So we need to make sure that we're using our charges to actually write out what the formula for it is. So mercury has got a charge of 2 plus in this. Does anybody know the charge of oxygen? Yep, awesome. So we're just going to have a 1-to-1 ratio of these. So we're going to just see HGO. Okay, so now I'm also going to include in my answer Hg, a little L next to it. Oxygen is a gas, so I'm going to include a little G as a subscript next to it. And then this one, we're seeing a solid, so I'm going to include a little S next to that for solid. Okay, and then let's balance it. Yeah, it's a nice, easy one to balance. So mercury 2 oxide is one compound. So the whole compound is a solid. So the state just goes at the end of the compound. Yeah. So we've got 1, 2, 1, 1. So we're just gonna put a 2 here. And a 2 at the mercury. Okay, so our answer 2HgL plus O2 gas goes to 2HGO, and that whole thing is a solid, that entire compound. All right. Next one, we've got a solution. So a solution is aqueous. A solution is always something dissolved in water. It's going to be something that's AQ. So I'm just kind of taking these words and pulling them out. Hydrochloric acid is going to be HCl. It reacts with calcium carbonate crystals. So calcium carbonate, it's an ionic compound with a polyatomic in it. It's CaCO3. Calcium has a 2+ charge, and carbonate has a, sorry, I'll do this. Calcium has a +2, and carbonate has a -2. So we get CaCO3 from that. Crystals, what's that? Solid, liquid, gas, aqueous? Solid, yep. To produce aqueous, calcium chloride. Okay, calcium has a 2+ charge. Chlorine has a -1 charge. So when those two combine, we get CaCl2. And then also gaseous, so that's G. Carbon dioxide, that's a covalent bond, so we've seen the prefixes, so CO2. And liquid, water. So my recommendation would be to like go through the whole thing, pull out all of the words, and turn the words into the symbols. Figure out where your arrow is. Find your word like produce or reacts to form or something. And then take that information and write it out linear without worrying about balancing it to start. So HCl, aqueous, plus calcium carbonate, which is a solid. It's going to produce calcium chloride, which is aqueous, and carbon dioxide, which is a gas, and water, H2O, which is a nice pure liquid. Okay, and then after we've done all of that work, we're going to balance it and write the answer. Okay, so I'm going to get you guys to go ahead and give this balance a go. Okay. Do we all have it balanced? No. Okay. So what we should get here is just a 2 in front of the HCl, and then everything else there's just 1 of, and that balances out our hydrogens and our chlorines, and everything else was already set. Okay, so basically from all of this, just make sure that you're including the states if they're given in the question, and make sure that you're using your knowledge of how to name things. So look, is it ionic? Is it covalent? Is there a polyatomic ion in it? And make sure that, for example, for calcium chloride, you're going through the charges and making sure that you write down CaCl2, not just CaCl. So all of those little things that we've learned over the last few units are really going to come in and be important in this. Yeah. Any questions about any of those examples? Pardon? Can we go on a break? Yeah, absolutely. Okay, so we're gonna work on page 113 when we come back, and I will hand out your quizzes. But yeah, you guys are good to do a break. Let's say like 15 minutes. Come back at 2.